Hi guys, I'm about to go over this review. All right, so on the first problem, or the first part of the review is asking us to determine relative extrema. So we need to figure out the relative max and the relative minimum. All right, so that means we have to check our first derivative and check to see when our sign changes. So when the slope changes from positive to negative, that means our graph would be going up, would be going down. So here, it makes it easier for us because we have our original graph. So these are the places, sorry. Oh man, sorry. No. That we have the relative extreme at the top and bottom of a curve. So it makes it easier for us when we have the original graph, but be careful, make sure what graph we're looking at. So relative max would be at the top of the curve. So that's at x equals 1.5 and 4. Relative minimum is the bottom of the curve. So x equals 0 and 3. Concavity is concave up and concave down. Since we have our original, we don't, so that would tell us that we would have to check our second derivative if we had our equation, but whenever we have our original graph, we can just look at the shape. So it's concave up over here from -3 to 1 and 2 to 4. Concave down from -infinity to -2. That's this part right here. It's concave down. Concave down right here from 1 to 2. Then concave down again right here from, well, actually, it wouldn't be 4. It would be concavity, sorry, from 3.5. That'd be 3.5 to infinity. And there we have it. So our inflection points would be where the concavity changes. So that would be at -2. This is -2, sorry. X equals -2, 1, 2, and 3.5. So that's how you tell from the original graph. Sorry. Now from the second graph, part B, they don't give us the original. So be careful here. They give us the derivative graph. Okay. So for our relative max, that's when our derivative, our slope, changes from being positive to negative. And then it's the relative max. A relative minimum is when our derivative, our slope, changes from being negative to being positive. So here we're not looking at the tip of the curves because this is not my original graph. Here I'm looking at the slope. These values are my slope because this is the graph of f prime. So my relative max would be when my graph or my value is positive and then changes to be negative. So that would be right here. Sorry. At x equals -4. because here it was positive. So that means on my original graph, it was going up, then it became going down. And that's it. That's the only place that it was positive and then changed to be negative. Relative minimum would be at x equals, so that would be when my derivative was negative, so that's down here, and then becomes positive. So that's at x equals -2. Okay. Now, concavity, concave up. That's when my second derivative is positive. Second derivative, well, I have my first derivative. How do I get my second derivative? That's the slope of f prime. That would get my second derivative. So that's when my slope is positive. So here my graph is going down. Here it's going up from -3 to 0. And then it's going down again, starting to go up again from -2 to 4. So right here at 4, the slope is 0 just for that quick second, but then it goes up again to forever. All right. Concave down. That's when my second derivative is negative, which means my slope of my f prime is negative. That's when we're going down. -infinity to -3. 0 to 2. Inflection points, that's when it changed. Sorry, and this pen is kind of hard to write with. -3, 0, and a 2. Oh, no, I keep doing that. All right. Now, this last one from the equation. So this is the one we kind of did with our notes. So here, this is where we have to do our number lines and sign chart. So to figure out my relative max and relative min, I have to figure out when my derivative changes signs. 3x squared plus 9x minus 30, which is 0. All right. So then I can create my number line for f prime. That would be at -5 and at 2. Plug them in. So say -6, that's negative, times a negative, and that 3 is positive. So negative times a negative is positive. Plug in 0, positive, negative. Plug in 3, positive, positive. So that makes my graph is going up, going down, going up. So a relative max at x equals -5, because that's, see how it's changed from being positive, negative, so that would be the top of a curve. Relative minimum at x equals 2, because that's the bottom of a curve right here. All right, now next is, I'll just erase this here since I'm done with that. Concavity. So when we do concavity, we have to do the second derivative. Set that equals 0. That would be x equals -9 over 6, which is -3 over 2. It doesn't matter if you want to keep it there or not. Don't worry about the fraction. Second derivative, plug in a number. here, like negative 10. That'll be safe. That would be a negative number. Plug in a number here, 0, positive. So that means it's concave down here, concave up. Remember, that's my second derivative. I plugged it into my second derivative. So concave down from negative infinity to negative 3 over 2. All right, man. Concave up from negative 3 over 2 to infinity. Where's my inflection point? At x equals negative 3 over 2. So all I had to do is do the sign chart whenever you have the equation. The graphs, you have to kind of look at the graphs since we don't have the equation. But all right. Remember, and you guys can pause, rewind back if you need to go back. Here, we have another graph of my original f of x. When is the first derivative and second derivative both positive? All right, so that's when is the slope positive? That's when our graph is going up. Second derivative means our concavity. That's when it's an upwards U. So that would be right here to right here. So here is going up and it's concave up. This is still part of my upwards U. Here, after this point, is that downwards U. Or else here, this part of the graph is going up and is part of the upwards U, so it's concave. All right, so it would be negative 4 to negative 2. And what is that? 1, 2, 3, 4, 5 to infinity in this case, because let's assume it just going forever, continuing with this. When is the first derivative and second derivative both negative? All right, so that's when we're decreasing part of the downward U, because second derivative means it's concave down. So that would be going down. This is still part of my upwards U here. Downwards U, this is where I'm going down. All the way up to here. Okay, so it's going down and it's still part of the downwards U. Now it goes up to the upwards U. So that would just be 0 to 2. And there we go. Oh, I don't know what I did. There I am. All right. Now we get to the next part. So use the tangent line to approximate f of 0.1. All right, so we got to get the tangent line first. That's the point slope. Y, or let's do this, x equals 0. Y equals, plug in 0, that's 3. M, that's our derivative, so f prime, sorry, what is that? 3/2 x squared minus 6x plus 5. Plug in 0, ends up being 5. All right, y minus y1 equals mx minus x1. Plug in 0.1. Now we can use this 0.1 to approximate this. So we'll plug that in, put the 0.1 in there now. So y minus 3 equals 5. 0.1 minus 0, just 0.1. So y equals 3.5, because 0.1 times 5 is just 0.5. Then move 3 over. So here's my answer. That's my approximation. So again, I'm not trying to plug in 0.1 into this. I'm trying to use it in the tangent line to approximate it. Now, is this an overestimate or underestimate? Okay, so remember, if it was concave up, our tangent line would be below. That would be an underestimate. If it's concave down, my tangent line would be above it. So that would be an overestimate. So I got to figure out if this concave up or concave down at 0, because that's where our tangent line is, at 0. So I get my second derivative, which is, 3x. If you multiply that, 6 over 2 is 3, minus 6. All right. Plug in 0, because that's my x value at the tangent line, and that's negative 6. So here, my second derivative is negative, so that must mean I'm concave down, so my line is above, so it's an overestimate. Because we could say, yeah, that would be good enough, is negative. That's what they're looking for. So this represents that this is concave down. How do we know this is concave down? Because this, and we justified it here. So there you have it. Now let's go to the back page. Here we have another graph. This time they give us a graph of f prime. Now find all values where we have a relative max. So a relative max means, what does that mean? That is when my derivative changes, my slope changes. Which way is it? Kind of visualize it. Yeah, it changes from positive to negative. The slope is positive, then it becomes negative. That would be all right. Well, it's easy to think right here, but that's not my original. That's if it was my original. So I'm not looking at the curves. I'm looking for when the derivative, which is these values, change from positive to negative. So that would be at x equals negative 3 and at 4. All right. Wasn't too bad. Relative min. Oh, no, it's not even asking for that. That was all for part A. All right, cool. That made it easy. And again, this was a real free response, you see. All right, so now we have part A. Part B is saying now point of inflection. All right, let me clear this. A point of inflection is when let's call it inflection point, shorter. All right. Inflection point, that is when my second derivative changes signs. So this is what you want to, when it's saying justify, that's what I'm writing over here. This is my justification. F double prime changes signs. So let's see where it changes signs. How do we know that? So F double prime is the slope of F prime. The slope of, that's what F double prime is, because we don't have an equation. It's not like we can just find F double prime. So here I got to relate it. So I'm telling them that F double prime is the slope of F prime. Okay. So that's when this, oh, right here, the slope is going up, then going down. So here, x equals negative 4. Where else? Oh, right here, negative 1. Oh, right there, at 2. And that's it. And there you have it. So that's where the slope of f changes signs. And there you have it. And that's the justification. So I do need this part right here, where it's the slope of f prime, because I have to relate it to what they gave me, because I don't have f double prime. So that's why I wrote this right here. Part C. Find where f is concave up and has a positive slope. Okay. So that's when, so here this is saying when they're both. It's not saying two separate questions. It's saying when is it f concave up and also when is it have a positive slope. So f prime is positive. That's for this part. Concave up would be when f double prime is positive. And what does this mean again? The slope of f prime is positive. All right, so there's my justification. So now I just got to answer it. When is f prime positive? Oh, that's just when, see, this is f prime. This is when it's above the x-axis. So all this. And when does it also have a positive slope? So that's when it's going up. -5 to -4. And also 1 to 2. Explain your reasoning on this. We just did. All right. Now, here we have another equation. So let's do that. Where is the function increasing? So that's, what do we have to say? That's when, they're not using f, they're using y. So that's when y prime is positive. So I just justified it already. Now I just got to do the work. Y prime equals 3 minus 3x squared. Okay. When is it positive? Well, that's when we had to do the sign chart and figure out the zeros. Move that over. All right. Plug back numbers back into the derivative. -2. Okay, what would that be? 3 minus 4, 12. 3 minus 12 is a negative number. 0. 3 minus 0 is positive. 5, let's say 2. And again, that's negative. When is it increasing? From -1 to 1. Justify it? Here. I just did. The sign chart's not your justification. You have to put it in words. When is a function decreasing? -infinity to -1. And 1 to infinity. Justify it. That's where y prime is negative. All right. Here, let me make some room. All right, let me just erase it, actually. Where the function concave up? So then we got to check the second derivative. That just ends up being 6x. Set that equal to 0. X equals 0. Negative, positive. From 0 to infinity. Justify it. Y double prime is positive. Concave down. Negative infinity to 0. Y double prime is negative. Points of inflection, x equals 0, because y changes signs. So the justification is basically what we're reading from our sign chart. Find all extrema and justify your response. That's going back. Oh, I erased it. I'm not going to do all that. That was my first derivative, and this is my second. Yeah, remember labeling. Be careful. All right. The extrema relative max. What is that? That's when my derivative changes from the top of the curve. X equals 1 because, let's put it right here. Or this is y. Sorry, y double prime. Y prime. I don't want to say just changes signs. Changes from positive to negative. relative minimum sorry, I got another semester. X equals -1 because we hide that. It's in the way. Because y prime, our derivative, changes from negative to positive. And there we go. All right, now I had asked y'all to write part G. So part G was absolute extrema on the interval from 0 to 2. Okay, so we have to get our y value, our y value at 0, our y value at 2, and our critical numbers, which when our derivative was 0 or when our derivative is undefined. In this case, our critical numbers were -1 and 1. But in this case, I just have to pick 1. Why? Because -1's not in my window, so I don't even have to worry about it. Just ignore it. So here, let me do this. Plug that back into our original. That's 5. Plug into, what is that? 6 minus 8, -2 plus 5, 3. And 1 be 3 minus 1 is 2 plus 5, 7. All right, so there we have. So that on this window, this would be my max. Or sorry, this would be my min. That's my lowest y value. This would be my max. This is not relative max or min. These are absolute. These are just the highest and lowest points on the graph in this window. If we zoomed in just to this window, we didn't see anything else. And that's it.